Hi students, good morning. In today's session, we will be going through some terms and after the session, you will be able to differentiate between haploid, diploid, polyploid and monoploid. So let us see what are these. We know that in each of the species, each species have a constant number of chromosome number. In every species, all the cells of that particular species will be having an accurate and constant number of chromosomes. And how is this accuracy maintained? This accuracy is maintained because of the accuracy which is happening in the meiotic and mitotic divisions. So, in this figure, with the help of this figure, you will be able to clearly distinguish between a haploid and diploid chromosome number. So here, this is a diploid case. So the chromosome number which is present in the somatic and zygotic cells of an organism are diploid, and we represent them as 2n condition. So here 2 copies of each chromosome will be present, and these two are homologous pair. These are the homologous pair and these are another homologous pair. So here in this figure you can see 3 pairs of homologous chromosomes. Each one of the pair will be from the maternal and paternal side. So if this is from the maternal side, this will be from paternal, and this, if it is coming from the maternal side, then it will be from the paternal side. Likewise here also. So here in this figure, this particular cell will be, if it is a cell, then it is having 3 pairs of homologous chromosomes. So each chromosome is found in pairs, and this type of diploid condition is found in the somatic and zygotic cells. And come to this case, here it represents the haploid condition. In haploid set, only one of the pairs will be found. So here homologous chromosomes will be present not in pairs. Only one copy of each chromosome will be present, and this type of condition exists in the gametic cells. So that is the difference. So haploid cells or haploid condition will be having a chromosome number which will be the exact half of diploid condition. See, here it is, total number is 6 and here it is 3. One from this, one from this and one from this forms the haploid. So I hope you are clear of these two terms. See here also, it differentiates between haploid and diploid, and another term is polyploid. What is polyploid? In polyploid condition, the organism will be, or the cell will be having more than one basic set of chromosomes. Here in this case, say for example, this is a case of a particular organism, and that particular organism is having the chromosome number as 3, and the haploid set of that organism will be only 3 chromosomes. The diploid forms this case. Here 3 pairs are seen, a total of 6 number of chromosomes. And in case of polyploid, if that organism or cell of that organism is induced to become polyploid, then what happens is more than 2 pairs will be present. See, yellow, a single pair is found in diploid, it becomes more than 2 pairs. Here 3 pairs are there. Likewise, the second chromosome, purple colored, it also in polyploid condition it is 3 pair. This also 3 pairs. So in this polyploid cell, it will be having more than 2 pairs of basic set. So if it is the condition, then we call it as polyploids, and that particular process or that particular condition is called polyploidy. So I hope you are clear with haploid, diploid and polyploid. So one more thing to mention is the polyploidy may be of different types. First one triploidy, second one tetraploidy, and it may be pentaploid. Likewise it may increase. So this is a haploid set, this is a diploid set. Only three chromosomes in haploid and 3 pairs are found in diploid. And here you can see 3 copies of each chromosome. If it is present, then we represent it as 3n, and that particular condition is called triploidy, and the cell with this condition is called triploid cell. If 4 copies of each chromosome is present, then that cell is called tetraploid, and that condition is called tetraploidy. Likewise, it may happen that 5 copies are present, 6 copies are present, and it may go on like this. So anyhow, if the number of chromosomes in a particular cell or in a particular species is more than 2 copies or more than 2 pairs, then we call that condition as polyploidy. And another term you have to be clear with is monoploid. Monoploid is the cell, or here in this case the chromosome number will be the basic number, or the basic set of chromosomes is called monoploid. Say for example, in case of a diploid organism, one example we can quote is of wheat, a species of wheat, Triticum vulgare, or another species, Triticum compactum. Here wheat is a polyploid species, and in this particular species vulgare, the chromosome number 2n condition is 42. Diploid number of chromosome is 42. And then what will be its haploid number? Haploid will be the just half of diploid condition. So diploid is 42, so haploid will be 21. But the difference is wheat is a polyploid species. So here the basic chromosome set is different. It is represented as X, and the monoploid condition X is equal to 7. So in this case the haploid number is 3 times greater than the monoploid chromosome number. So but in case of a diploid species, the monoploid is equal to haploid number, because the organism is diploid and the haploid will be just half, and monoploid is also equal to haploid number. So that is the difference between monoploid and haploid. It is not always equal to haploid number. In case of polyploids it is different, but in case of diploid organisms it is equal to haploid number, and monoploid is represented by the letter X. So I hope you are clear with all these terms: monoploid, haploid, diploid and polyploid. So this changes in monoploid number are generally called mutation, and the changes in diploid number are called as ploidy changes, and we have to go through the next topic, that is ploidy changes. We will go through it in the next session.